Well, good afternoon. My name is Dan McNary. I'm the Agricultural Science and Technology instructor at Crook County High School and also the OATA President-elect. I'd like to welcome you to the Ag Ed 101 Learning Series Roundtable. Today's presenter is going to be Kathy Mayfield. She is the Ag Science and Technology instructor and FFA advisor at North Clackamas Schools and the Land Lab there at North Clackamas.
Thank you, Dan.
Our presentation today is going to be over Agri-Science Projects and Fairs. And as we look at that, I want to remind everybody that the reason that we are doing these 101 series webinars is to focus on our agricultural education model and how each and everything that we do fits into that model in some way, shape, or form to assist our kids in being better. As we look at our model, we see that we have a circle that is dedicated to the education that happens within the classroom and laboratories of our program. You can also see that we take FFA and give students an opportunity to apply what they've learned in the classroom in either competitive or application-based experiences, both from the standpoint of career and leadership development. Finally, our third model is supervised agricultural experience, where they take those skills learned in the classroom, applied through FFA or practice through FFA, and then apply them to a business model of their own, where they receive guidance from their agricultural education instructor and FFA advisors. Today's topic, Agri-Science Fair and Projects, certainly fits into all three sections of the model. Kathy will be working with us today to go over whether this is applicable to the classroom and competitions or both. She'll be giving us tips on how to apply these and utilize them in our classrooms. She'll be discussing with us the categories that fit into agri-science, giving us steps for success, as well as outlining what a good project looks like. She will also be talking to us about the agri-science fairs at the state and national level and pointing us towards resources that we could certainly use to make this happen in our classroom. So with that being said, I'd like to take just a second and point out that this is part of a series, and we do have other opportunities to sit in on these webinars, and I would encourage those listening to talk to the educators in their districts and point them towards these upcoming dates. On the 27th of this month, we'll be having our webinar roundtable focused on county and state fair projects. And we will be moving into March, where we'll cover shop management, and you could see the list there. As we get into the webinar and you have questions, please feel free to go ahead and type those into the chat. And we will have a session after Kathy goes through the Agri-Science Fair project to direct those questions to her, and she will help us in answering those questions.
Well, thank you, Dan. I'm excited to be with you today and talk about Agri-Science projects. I've been pretty excited about doing Agri-Science projects in my program. I've seen a lot of benefit to students. In fact, I was just visiting with one yesterday who got done competing this fall, and she said she felt like it prepared her more for her classes in college than any of her college prep classes. And she's excited because she's going to be doing research in college that relates to the research project she did in high school. So that's always rewarding as a teacher, to be able to know that maybe what your students are doing is beneficial to them. I think that one of the first questions as a teacher you have to ask yourself, especially if you've not started down that agri-science path, is, do I try to teach it to all my students that I have in a particular class, or do I just kind of turn a few loose to kind of dabble in it and try it and participate in an agri-science fair? And I think that either answer is a good answer, because I think it's beneficial for kids. I've done both. I actually alternate teaching agri-science. I do it every other year in my advanced level class, where all students have to complete an agri-science project, and then in the off years, we just offer it to students who would like to compete. But I follow the exact same process, irregardless if I'm teaching it in class or if I'm just supporting students doing a project. So I'm going to kind of go through my classroom model and then kind of just the agri-science fair piece. When I have my students in class do it, we actually start with a class project together, and I do a real simple experiment just involving different microwave popcorn, just so that they can learn how to correctly write a hypothesis, collect data, and how do I put that data into a chart and learn a little bit about Excel, and how do I interpret that data. And I can do that in 1 or 2 class periods. It doesn't take a lot of time. And then from there, we start kind of in that next step. And in doing that, I found a great resource on some tips in terms of how do you help students generate ideas. And that seems to be a big hang up for students when you say, every student in class, either individually or in a pair, you're going to complete this research project. And so posing some questions to them kind of helps get their brains in gear in that brainstorming session. And this particular resource I thought had some great questions that you could pose to students to help getting them thinking about what are some real life problems in agriculture that could be answered by students doing an agri-science project. So I make my students align their projects with the National Agri-Science Fair categories and divisions, because it only makes sense that if they get into their project and do a great job, many of them actually are pretty proud of what they do, and then they want to compete at the state competition. So I just reference the 6 divisions, categories and divisions, and really want to point out to teachers, if they've never done this before, there's 36 opportunities to plug kids into an FFA event due to the 6 divisions and the 6 categories. And in Oregon, we don't have all those divisions and categories filled every year. And so I think there's a great opportunity for some students to experience some pretty immediate success in an area that really could be further developed in our state. So moving on. So what I do when I start out with my kids is National FFA on their website has a template that is laid out, and I definitely use that template for them. Every student in class has to use the template. And in doing that, I set very specific deadlines on a calendar for them to help keep them on track. And the first step in that process is their project selection. I help them to think about how can I identify a problem to solve, thinking about maybe their SAE. Do they have a problem or a challenge within their SAE they'd like to solve, or something that they want to know, and help develop that, because those students who can relate it to their SAEs usually have total buy-in to their research because it's really relevant to them. And I try to do that in September. After that, I have the students research the particular situation. And so when I say research, most students just want to do their typical Ask Siri or Google. But what that really is referencing is what other scientific research has been done related to that problem. And this is where students really need a lot of help, because I'm not sure that they've ever read a lot of other scientific research that exists out there. And they have to really understand how to search for that and what to type in that search engine to get related scientific research. And then how do I interpret what other people researched, and how does that apply to me writing my hypothesis and moving forward? And so we spend time in class looking at research and understanding what it means and what implications that has. The third step is project design. And once they decide what they're going to research on, how do they correctly write a hypothesis, or what a null hypothesis is, identifying their controls and variables, and how exactly am I going to collect that data? What does my data collection sheet look like? And then I stop them at that point, and I don't let anybody move forward until I review all that and make sure that everything is correct and that the data that they're collecting will actually support their hypothesis. And I make them rewrite and redo if it's not on track at this point. That way they can experience success when they actually conduct their research. If kids are competing, this is pretty important. There are some human vertebrate and non-vertebrate guidelines in the handbook that FFA provides. I think it's very, very important that even if kids are not competing, that as ag teachers, we have those students follow those guidelines on the use of human vertebrate and non-vertebrate specimens in our research to make sure that there's no animal neglect or abuse going on in any of our research projects. So I just wanted to point that out. Step 4 through 7 really is smooth sailing once the kids are on track to do their research. So they actually conduct their research, and at this point, we hope they're going to get good data and lots of pictures. Their logbooks are very important, and they're a very important part of their learning process as they can reflect back when they do their interpretation of data. And I allow my kids to do it kind of October through January. And then, of course, the data interpretation, I spend time in class actually teaching kids how to use Excel, how to put formulas in, how to create charts and graphs. And we spend sometime in January and February on that. And then we start writing the report. And again, the template that National FFA provides is very good for that. And then after that, I have every student in class design a poster, even if they compete or not. Those who compete, we go ahead and print the poster, and the other students have to present off of the poster they design. And I have them use PowerPoint. I design a template for them that is the correct size poster. And so this particular guideline that I've used in class is really a minimum amount of time to do what I'm going to call a quality research project. Some of the kids might choose research projects that they might collect 1 or 2 years worth of data. And so we need to make sure that we help those students really align their research for that particular time frame. So if you're at that point going to have kids compete in the Agri-Science Fair, of course our state competition is at state convention. It's really important that you read the rules. There's some very specific rules around the size of the posters and what they can use during their interview, making sure that they have their logbook done, and then turning in their lab reports. There is a rubric that is used to score those lab reports, so it's really important that you give those kids the rubrics as they're writing. In preparing for the interview, I have my students talk about their research with other students. I have them present in class. They need to be able to just really discuss what they did, why they did it, their process, and what they learned in that actual interview process. And then having other people ask them questions about their research, why they chose to do it a certain way, to make sure that they can defend what it is they did. And so at that point, then they're pretty much ready for competition. So somebody asked me, how could you define what a good project is? And I kind of came up with these 8 points. I think one thing that really helps to define a good project is it an authentic problem in agriculture, and maybe one that hasn't been done over and over again. The student that I had compete at nationals, really interested in poultry, really wanted to know with the VFD, the Veterinary Feed Directive, and the increased concern about the use of antibiotic feed, wanted to know, is there something else we could use? And so she looked at what humans do, and there's antioxidants, of course, that humans take to increase their immune system. And so she thought, well, why can't I use antioxidants on chickens? And it just so happens that Foster Farms was conducting similar types of research at the exact same time. And I feel like that's very authentic. And then she can have current conversations with people in industry about what she's doing that is real life problems in agriculture. And I think that really provides that authentic piece for kids. You want to make sure that the scientific method is correctly applied to the research. Otherwise, they're going to get hammered pretty hard in the scorecard. Utilizing science teachers to maybe help with that design piece if you're not sure how to help them do that. Making sure their hypotheses are very well written. The if-then statement, making sure you have your variables, correctly identified is also very important. Good data collection that supports the hypothesis. And if you can have the kids do repeat trials, it adds to the validity of the data. Some people say, well, how many is enough? Well, the more, the better is the answer to that. If they can somehow use any kind of statistical analysis, that is going to increase the strength of their project. And of course, well-written lab reports, which is going to require lots and lots of proofreading. because if they make it past state and move to nationals, boy, that rubric is followed to a T. So those are my 8 tips for good projects. So if you are fortunate enough to have kids move on to the national level, the written lab reports are submitted for summer judging sometime in June. You got to check the calendar for that deadline. And those are judged back there in the summer following the rubric. And only the top 12 to 15 projects are selected for students to actually bring back to nationals to compete. I've been fortunate that I've had some great students who have been selected to do that, who then get to present at nationals. So then, of course, you get to take a poster back with your logbooks and have them present to judges at nationals. The one thing that I've found this last year that I thought was pretty intriguing is, boy, the projects have really, really increased in terms of complexity and depth of research projects. Almost every top 3 agri-science project involved what I'm going to call really higher level scientific skills, expensive lab equipment, bacterial counts, microbiology, high level science application coming out of STEM schools that have incredible labs. So it's becoming a little bit harder and harder to compete at that level without some outside assistance from people with resources like that, would be my, comment on that. So where does that leave us? Here's some resources, the template and some scoring rubrics on the website. Utilizing community resources is pretty important. If proofreading lab reports is not something that gets you real excited, I would encourage teachers to seek out assistance from science teachers or English teachers for the writing of those lab reports. It's so incredibly important to score high with those rubrics. So with that, are there questions?
Thank you very much for that. There are a couple of questions here. If you could take a look at these. Do you have students conduct the research at home or provide time in school? Or does it really come down to what their project is? That's from Kelly Friels.
That's a great question. I've had students do both. And of course, I'm in a particular unique situation because we are on a school farm. I highly advocate our students conducting research on our school farm because we have so many resources available here that they don't have at home. I have had students, however, conduct the research at home. It becomes a little bit more of a challenge to help provide the support they might need to do that. But I think both are viable, especially if students want to do research related to their SAEs and their SAEs are at home. I think that both can be very viable.
Thank you. Tess Hamby is asking, where do you have students start for their ideas?
Where do I have them do what? So in the handbook, I believe it's in the handbook, National FFA kind of provides a list of project titles, which gets you thinking. I also have them research current existing problems in agriculture. And of course, my kids are very, animal specific. So if they show lambs, I say, what are some challenges in the sheep industry that they're trying to overcome? What are some challenges in the food industry? So I have them kind of look at what's currently going on in agriculture and then what's some current research that's going on in agriculture. So then we have conversations to just help them brainstorm.
Allison Meadows is asking, do you encourage students to do social science research, and what are some good projects you have seen?
I do encourage, if kids really want to go that route of social science, do spend quite a bit of time about what's really authentic in terms of some social science projects. And again, I relate it back to if you basically conduct a survey, because that's what the social science ones are, is conducting surveys. How is that information gathered going to help or assist a problem within agriculture? So a couple of years ago, I had students, and I thought this was a good project, were really interested in the beef industry. And so they did theirs around all the labels that exist in the beef industry, organic, all natural, pasture raised. They came up with a list and surveyed people on their level of knowledge. And from that, their conclusion was that the industry needed to streamline and do a better job of not having so many labels to move forward and educate the public. So I try to get them to think about, how can my survey assist or help agriculture move forward or educate the public?
We were actually just talking about that in one of my classes today, about the number of labels that you see when you walk into a retail outlet in the meat case. So
yes,
I'd actually love to have that one to read the results.
Yeah, it was very interesting.
A couple more questions here. Do you have any specific websites that you recommend to find research papers?
Not specific websites, but what I have found when we search other research, I have to think about how I type this in. I tell the kids specifically to type in Google scientific research related to whatever their topic is. And if you put in scientific research related to, you'll actually get abstract of other research.
Lindy Cruz is asking, have you found any companies or corporations that have been willing to sponsor projects that might cost students more money to complete?
You know, I have not spent a lot of time looking in that avenue. However, we have access. Daimler Corporation has donated money to our school specific for science equipment. And each of our programs within Sabin got a pool of money. And with that, I purchased some equipment that some of our students needed in order to conduct the research. I had another student apply for, I don't know, it was like a Target grant or something, because she wanted to rent a machine a monitor that would evaluate the amount of gases in the air. We were giving a sow that was in a crate a particular supplement to see if we could reduce the amount of ammonia and sulfur and some other gas in the air, and she had to have a certain piece of equipment to measure that. So we've written grants and utilized some of our school money, but I have not explored other businesses.
That actually a really good job of answering another question we had about how you seek out funding and budget for this for your classroom. Is there anything else that you might put in as far as preparing a budget for this each year?
As kids are brainstorming, I'll tell you that I give them some parameters and tell them that if their project is going to cost money, they have to come have a conversation with me so we can talk about what the cost is. But where a lot of our kids have their projects on our facility, of course, again, we have tons of animals. We have lots of things available here. I give them parameters that they can't exceed what our normal work budget is. It can't increase the workload of any of our student employees. And so if it requires daily attention, they physically have to be here every day to take care of it themselves. So I give my kids some of those parameters. On some of the projects, like the broiler project, I use some pathway funding to cover some of that. And in the end, we sell the product to customers to help pay for the expenses.
You had mentioned that you have a lot of your students working with the stuff that you have on the land lab there, whether it be in the greenhouses, whether it be with the animals. Do you have many students, or how do you encourage students to do a project that's outside of their SAE? Or do you find that most of your students kind of focus in on that?
Most of my students end up doing something related. So like the two girls that did the social sciences around the beef labels, one of them had shown steers for 2 years, so she had an interest in beef, and then she just found a partner to do it with her who didn't necessarily show animals but had an interest. A lot of the kids end up doing something that is somewhat related to their area of interest, or sometimes I don't know, they come out of the blue and I'm like, really, this is what you're interested in? And I don't know, either they read an article or they found something that just triggered something in them. So we probably spend 2 or 3 class periods just brainstorming. I give them each of those 6 categories and I make them find things under all 6 categories to research before they land on a final decision.
I think the last couple of questions center around the posters that are being made for the project. Are you printing those at school, or do you have a company that is doing that for you online or in town? How are you having that done?
Well, I'm fortunate enough that we have a design program at Sabin, and they use some of their pathway dollars to get a really good poster printer. So she prints them for me very inexpensively. She only charges me like $30 a poster. I do know of other ag teachers who will send them to any one of the, print shops, the Office Depots, Office Max, to have them printed. I do not know what that cost is, however. So I'm fortunate that I can have them printed that way.
And then lastly, and I think that as we went through the presentation, there's certainly some information on this, but do you have junior high students, or is this a way that junior high students can compete at state convention?
I would say if you are a school that has junior high students in your program, yes, one of the divisions is for 7th, 8th, and 9th graders. No, 7th and 8th graders. The new category is 7th and 8th graders, and then 9th and 10th graders, and then 11th and 12th graders. So if you have those junior high kids in your program, there is a division for them.
Looking, and I am seeing that all of those questions, I believe, have been answered. Is there anybody else out there that has any further questions before we move forward with this? Well, I'd like to go ahead and thank you, Kathy, for presenting with us today. You obviously have a tremendous amount of knowledge in this topic, and you come across, and I know you're very passionate about it. And we thank you for taking the time to present to all of us, and we really appreciate it.
Yes, hopefully it will be helpful.
Yep, absolutely.
Kathy, would you mind selecting 2 numbers between 1 and 20?
How about 11 and 17?
So 11 and 17 going to be Rob Holbeck and Kelly Frills are the gift cards winners for this webinar. So congratulations to the winners, and the winners are sponsored by our sponsors, and specifically Wilco has jumped in with an extra donation to it, and there's a $25 gift card that'll be arriving in the mail shortly.
Perfect.
And that will conclude our webinar. Thank you everyone for attending. Dan, any final comments?
No, I appreciate everybody tuning in and look forward to having these posted. And thanks for having me, and we'll see everybody on the 27th, where we're going to be talking about county and state fair projects.
Very good. Thank you, everyone.